Today, on how it's made. Motorcycle engines. Glass enamel sculptures. Handmade paper. And vaulting poles. The V-twin motorcycle engine actually dates back more than a century. Talk about staying power. Central to the design are two cylinders that form a V around the crankshaft. This configuration is more compact than a straight-line engine, and its appeal is timeless. With its throttle cranked, the V-twin can take you on an exciting ride and leave sedans in its dust. To make one, a robot loads a cylinder into a machine equipped with cutting tools. The tools mill the cylinder's metal slats to highlight them. The slats are called cooling fins. They allow the engine's heat to dissipate. This cutting tool bores into the center of the cylinder, carving it to precise dimensions to allow engine components a perfect fit. Next, an operator assembles the crankshaft. He aligns connecting rods and slides them over bearings. He then assembles the rods and bearings to the crankshaft. A machine press fits everything together. Next, a lift scoops up the crankshaft assembly and transfers it to the lower half of the crankcase. At the next station, an automated dispenser precisely applies sealant to the inner edge of the crankcase. They then arrange the upper half of the crankcase on the lower assembly and bolt the two together. It's now time to link the crankcase and shaft assembly to the transmission. This chrome-plated cover is the finishing touch. Next, they fit the camshaft into the crankcase. Its job is to maintain valve timing. They position the pistons on the connecting rods now installed in the crankcase. Remember those highlighted cylinders made earlier? Workers now slide them over the pistons. These are the cylinder head castings. Technicians paint them and then machine them to fit on the cylinders. A robot bolts them together with just the right amount of torque. The operator then installs tubing that will house push rods. He snaps them into the cylinder heads. Then he clips on metal covers to secure them. He now inserts the push rods in the tubing. Up next is the electronic fuel injection system, which controls the flow of fuel to the engine. They install it between the two cylinders. A special bracket holds the injection system in place. He bolts the rocker boxes to the cylinder heads, then tops off the assembly with more gleaming chrome covers. The operator now screws the oil filter onto the engine case and secures it with a special wrench. This is the electrical charging system. It goes on the crankshaft. Now it's time to pump oil into this V-twin engine and put it through its paces. Computerized testing equipment moves in and mates to the engine. The engine rotates and they shift the transmission through all the gears. This allows the testing equipment to analyze every aspect of its performance. Next, they insert spark plugs into the cylinder heads. And these 1584cc motorcycle engines are now revved and ready for their wheels. Enameling is the process of fusing colored glass to metal with intense heat. This decorative art developed more than 3,000 years ago. The earliest enameled objects found are pieces of jewelry made in ancient Greece. Today, artisans most often produce glass enamel on copper. Artisans handcraft these magnificent sculptures by fusing vibrant colors of finely ground glass to solid copper. First, the artist draws the design, then chooses the glass colors from a palette of hundreds of shades. She takes one element at a time and makes multiple copies of it on a sheet of paper. She has a lab produce a film negative, which she lays in an exposure machine. On top, she lays a silk screen coated with a light-sensitive chemical. It exposes them to halogen light for 90 seconds. The film negative works like a stencil. Its dark parts block the light from hitting the screen, while its clear parts allow light through. Where light penetrates, the light-sensitive chemical reacts and hardens. The unhardened chemical rinses away, leaving just the image behind. In the next department, they lay the screen in a silkscreen printer, apply chemical-resistant ink, then load a sheet of solid copper about 0.5 millimeter thick. The machine automatically prints the image onto the copper. They cure the ink in an oven for 20 minutes, then repeat the entire exposure process for the backside of the sheet. Next, they feed the sheet into a two-step milling machine. It applies chemicals that eat away any copper that isn't coated with the chemical-resistant ink. This cuts out the shapes. Then it strips off the ink, which by this point has served its purpose. Now they have a blank shape, but it's completely flat. To give it dimension, they stamp it with a forming die. Now the enameling process can finally begin. For each color grouping of the design, there's an aluminum stencil. They lay down the first one and sprinkle glass powder in the first base coat color, which looks white now, but comes out clear. Then a second stencil for the second base coat color, white. The shape then goes into a kiln for about a minute to liquefy the glass powder and fuse it to the copper. Once the base coat cools, they create the detail work with additional stencils and colors. This is where the true artistry comes in. Each shake of powdered glass is like a painter's brushstroke. Too much, and the color will come out too dark. Too little, and it'll come out too light. It takes an experienced enameler to get it just right. They craft dimension by blending colors and by combining different types of glass in the design, some transparent, some opaque, some opalescent. After every few powder applications, they return the piece to the kiln, where the intense heat, 870 degrees Celsius, liquefies and fuses the glass to the copper. Slowly but surely, they turn what was a blank copper shape into a vibrant work of art. Meanwhile, an artistic welder skillfully creates the sculpture's metal framework. In this case, branches on which copper-enameled birds will perch. He's using steel, but frameworks can also be made of copper, bronze, or brass. Besides birds, this sculpture features copper enameled leaves and flowers. Their stems are bronze, because bronze fuses easily to steel. With the framework and background elements in place, it's just a matter of attaching the main design elements. Some industrial-strength hot glue does the trick. A modern twist on an ancient craft, these glass enamel sculptures make a glistening impression. Today, most paper is made from wood pulp, treated with chemicals and mechanically processed. Making paper by hand is a craft that involves techniques and materials that go back over 2,000 years in China. These techniques have evolved over time, but the main ingredient remains the same: imagination. Handmade paper is a distinctive choice for a variety of uses, from fine stationery to limited edition prints. Natural fibers like linen or these cotton remnants are the raw materials for handmade paper. Workers place the cotton rag on a conveyor, which leads into a machine that chops it up into small pieces. It collects in a bin, ready for the next step called beating the rag. Workers pour out the chopped up rag into a tub called a hollander that's filling with water. This machine beats the material into a pulp. Its only moving part? A large roll weighing several tons, equipped with metal blades. Workers fill the hollander with up to 800 pounds of rag. Once all the rag is in, the giant roll descends to begin the beating. Water pours down to soak the fabric as workers push it toward the roll. They sometimes take paper from previous batches, known as broke, and add it to the mix. They may also add a little dye to adjust the color, depending on the desired effect. After 8 hours of beating, workers feel the pulp's consistency. They will then take samples from this batch to make sure it doesn't contain any unbeaten rag or knots. Next, they add colorful scraps of paper to the pulp to create a decorative pattern. To make a sheet of paper, the vat man plunges a wooden mold into the pulp. As he lifts out the mold, he shakes it to even out the pulp. Water pours out, leaving only fibers caught on the mold's surface. He removes the mold's frame, known as the decal, and lowers the corner of the mold to drain away more water. He places the mold face down on a wet felt, then carefully lifts it away. A sheet of paper now lies on the felt, which he then covers with another wet felt. When pulp pours through the mold's metal screen, it traps the fiber and lets the water through. The vat man plunges the mold once again into the pulp and couches another sheet of this distinctive paper. At this point, the paper is 99% water. Workers bring a stack over to a hydraulic press to draw the water from the paper and link the fibers together. They press the papers with care so they don't burst right out of the felts. They brush any leftover pulp from the felts, leaving them clean and ready for the next batch of sheets. Now workers can handle the paper without it falling apart. They take the sheets from the felts and hang them to dry on plastic tubes. Once dry, they collect the sheets according to type and stack them for a final finishing press before they go on for shipment to customers around the world. The mold's frame leaves a feathery edge, a distinctive feature of handmade paper. These papers are available in more than 30 colors, in various finishes, from smooth to rugged. There's a paper for every project, whether it's etching, watercolor, drawing, or even folding. Pole vaulting began as a mode of transportation, not a sport. In Europe, men would use poles to propel themselves across bridgeless canals. In the late 1800s, pole vaulting caught on as a college sport. The athletes used bamboo poles to vault themselves over a horizontal bar. Today's poles are incredibly lightweight, yet strong enough to absorb the vaulter's energy, then throw it back to propel him over the bar. Some poles are made of carbon fiber, others out of this material, resin-impregnated fiberglass. The first step is to spread out the material and cut out the pole pattern. Meanwhile, a slitter machine cuts the same material into strips of a specific width. Then it winds each strip into its own roll. This spiral wrap machine automatically unravels the strip and wraps it around a hollow steel tube called a mandrel. This first layer of fiberglass gives the pole its flexibility. They wrap a second layer in the opposite direction, employing a crisscross pattern to increase durability. This second layer fortifies the pole's circumference. For the next layers, they remove the mandrel and lay it on a table. Now it's time for those fiberglass patterns they cut earlier. They heat the edge of the first one with an iron, melting the resin in the fiberglass until it's tacky. They stick this edge to the mandrel, then slide the other end between heated rollers. The rollers wrap the rest of the material around the mandrel, the heat activating the resin in the process. The same procedure now with a second pattern. This piece is critical because the way it's cut controls the way the pole bends. The mandrel and its multi-layer fiberglass coat now go into an oven. The heat, generated by steam, starts at 79 degrees Celsius. This liquefies the resin so that it resaturates the fiberglass. Then the temperature gradually rises to nearly 150 degrees, solidifying the resin again, curing it. This entire process takes about 45 minutes from start to finish. And when it finishes, a pole extractor slides the mandrel out of what is now a fiberglass pole. The pole moves onto a flex machine. In part, this is a stress test. If there's any type of defect, the pole will crack or break. But the flexor also permanently puts a specific degree of curve in the pole, which helps the athlete vault higher. Now they make what's called the soft side mark. This helps the pole vaulter locate the bend in order to know where to grip the pole. Next, they apply a maximum weight label indicating how heavy the vaulter can be. To finish the surface now, they mount the pole on a spindle, then run a polishing pad over it. Using a solvent, they clean off the debris. Now that the surface is pristine, they wrap it in thin, lightweight tape. Different colored tapes designate different pole styles. They cap the top of the pole with plastic. Then at the bottom, mallet on a molded tip made of hard rubber. The finishing touch is the manufacturer's decal. Vaulting poles come in various lengths between 3 and 5 meters. A pole designed for a heavier vaulter has to be stiffer than one designed for a lighter vaulter, because the pole has to propel more weight with the same degree of bending.